Good evening, students. Now we'll solve more numericals on trigonometric functions. Now see, we'll try to sort it out. Now the question given is about cos square 2x minus cos square 6x. So we need to prove it to sin 4x, sin 8x. Okay. Now this is we need to prove in that numerical. Let us see how we will able to solve this by using a specific formula. Okay. Now let us take first LHS. Cos square 2x minus cos square 6x. Now a square minus b square is identity which will need to apply here. Okay. So I got this. A square minus b square is equal to a minus b into a plus b. Okay. So this is what we have, a minus b into a plus b. Now we'll apply the formula for that. For the identity we have a minus b is equal to minus 2 sine a plus b by 2, then sine a minus b by 2, and here we will apply the formula for cos x plus cos y. Will have 2 cos x plus y by 2 and cos x minus y by 2. Okay. So this is the identity I am using it, that is cos x minus cos y and cos x plus cos y. Okay. So what is cos x minus cos y? That is minus 2 sine x plus y by 2 and sine x minus y by 2. Okay. And I am using cos x plus cos y, that is 2 cos x plus y by 2 and cos x minus y by 2. Okay. So I am using it. Now I got 4 minus 2 sine 4x. Now sine minus 2x. Now here I got 2 cos 4x. I reduced this by, so I got minus 2x. Okay. Now we can solve simply like, now we can take it like this is minus cos 2x, cos minus x is cos x and sin minus 2x is minus sin 2x. So minus into minus, it will be plus 2 sin 4x sin 2x, 2 cos 4x cos 2x. Okay. See, now 2 sin x cos x sin 2x. So 2 sin 4x cos 4x got sin 8x into 2 sin x cos x, I got sin 4x, which I need to prove that is equal to RHS. So I have here used the identity 2 sin x cos x is equal to sin 2x. Okay. So this is the identity which I have used in this numerical. Now we'll move to the next numerical. Okay. Now we'll move to the second numerical. Okay. Now second numerical which is given is sin square 6x minus sin square 4x is equal to sine 2x sine 10x. Now let us prove with the identity here. Now we'll first use the LHS, that is sine square 6x minus sine square 4x. Now here I will use same identity which I have used in the previous example, sine square a square minus b square, that is a minus b and a plus b. So I have used here the identity, that is a square minus b square, which we have studied in class 9th in polynomials, that is a minus b into a plus b. Okay, now what is identity I am using here? Sin x minus sin y, that is 2 cos x plus y by 2 sin x minus y by 2. Similarly, sin x plus sin y, 2 sin x plus y by 2 and cos x minus y by 2. Okay. So now I have reduced them. So I got this 2 cos 5x and sin 5x. You can rearrange them like this, 2 sin x cos x. Now I will use the identity, that is 2 sin x cos x, so it will be sin 2x, sin 10x. Here I have got sin 2x. That is what we need to prove. That is why got the RHS. So I have here used the identity, sin 2x is equal to 2 sin x cos x. I hope it is clear now. We'll move to the next numerical. Now see, we have solved this kind of numerical here. So we'll move to the next one. Now let us move to the next numerical we have. That is, here also we need to prove, that is okay. So this is the given question, that is sin n plus 1 into x into sin n plus 2 into x plus cos n plus 1 x cos n plus 2x is equal to cos x. Now let us see how we can able to do it. So here, now take the LHS, that is sin n plus 1x into sin n plus 2x plus cos n plus 1x cos n plus 2x. Okay. Now, right now, let us try to divide in two parts, A and B. So first of all, we'll solve A part, that is sin n plus 1 x sin n plus 2x. Now what we will do is just multiply by 2 and divide by 2 so that it can become formula. Okay. We have the identity which we will use to apply now, that is 2 sin x sin y. We'll use here, that is cos x minus y. Okay, we have the identity for that case, minus 2 sin x sin y cos x minus y minus cos x plus y, x plus y. X plus y. So now I got what here it is. If I open the bracket, okay, so I got this one. Okay, so I got this here. I am adding on this, so I got this one. So I got half cos x minus cos 2n plus 3x. Okay, so I got this one now. Now we'll sort it out p. Now let us see how p will be solved out. Let's solve. Now b is given. What will we have? Cos n plus 1x cos n plus 2x. Here also we'll multiply and divide by this. Okay, now it become formula 2 cos x cos y, that is cos x plus y plus cos x minus y. So now I have solved both. Now what we'll do, we'll put these both values in first. Okay, now I got, that is half, we take common. Now cos x minus cos 2n plus 3x. Okay, 2n plus 3x, 2n plus 3x here, plus cos 2n plus 3x plus cos x. So what I will got here, we'll reduce this, right? Cos x plus cos x, 2 cos x. So here I will reduce with 2. Now we'll got only one, that is cos x. Okay, what is required? Okay, that is called LHS is equal to RHS. So like this we solve such kind of numericals. Now we'll try to solve more numericals. Now let us see the next one. Now see the next numerical we have, that is given sine 2x plus 2 sine 4x plus sine 6x. We need to prove it to 4 cos square x sine 4x. Okay, let us see how we can solve it. So now, well, first of all, take LHS. LHS is sine 2x plus 2 sine 4x plus sine 6x. Now, in this type of numerical, what we can do is take sine 2x plus sine 6x. Sine 2x plus sine 6x plus 2 sine 4x. Okay, so this is they have given. Now we can apply the formula sin x plus sin y. So the formula for the sin x plus sin y is given. So now we can see here it is now 2 sine x plus y by 2 cos x minus y by 2 plus we have 2 sine 4x. Okay, now we have this. Now 4 2. Now what is left with 2 sine 4x cos minus 2x plus 2 sine 4x. Now we can take 2 sine 4x. Okay, Now, what is left with it? Cos 2x plus 1. Because you all know cos minus x is equal to cos x. Now, we're left with this 2 sin 4x cos 2x plus 1. Now, what we can do is just put the formula here for cos 4x, that is, which formula we have applied? Cos 2x, that is cos square x minus sin square x. And here, from by 1 we can write here sin square x plus cos square x. Okay, so that it can be reduced. So now we have 2 sin 4x cos square x plus cos square x, 2 cos square x. So I got my answer 2 cos square x sin 4x, which is required 22, sorry, it will be 4 is equal to RHS. Okay, so you can easily solve such kind of numerical. Okay, so this is. Now let us solve next numerical regarding this. Now the next numerical we have, that is what we need to prove, is cot 4x sin 5x plus sin 3x is equal to cot x sin 5x minus sin 3x. Okay, now we'll try to see which identity will be applied in that case. Let us take first LHS, that is cot 4x sin 5x plus sin 3x. Okay, now what we can do here, we can write cot 4x is equal to cos 4x upon sin 4x. Now we'll use the identity here, sin x plus sin y, that is 2 sin x plus y by 2 cos x minus y by 2. Okay, so what I got here, what I have used here, 2 sin x, what I have used here for sin x plus sin y, that is 2 sin x plus y by 2 and cos x minus y by 2. Okay, so now what I will get here, 4. Now we can see here cos 4x upon sin 4x into 2 sin 4x cos x. Okay, so what I got here, by reducing this, I got 2 cos 4x cos x. Okay, this is what I got. Now in this type of numerical, we need to solve both sides, LHS and RHS. Now let us move to the RHS. Now for the RHS, it will be cot x, now sin 5x minus sin 3x is given. Okay, so again I can write cot x, that is cos x upon sin x. We all know that cot x is a reciprocal of sin x. Now sin x minus sin y. So what is that? 2 cos x plus y by 2 into sin x minus y by 2. Okay, 4 here. So what I got here? Cos x upon sin x into 2 cos 4x sin x. So finally I got my answer, that is 2 cos 4x cos x. So you can see we got our answer. LHS is equal to RHS. LHS is equal to RHS. Hence, proved. So likewise, we can solve such kind of numericals. Now we'll try to solve next numerical now. Okay. Now the next numerical we have, that is what we need to prove, is cos 9x minus cos 5x upon sin 17x minus sin 3x, okay, is equal to minus sin 2x upon cos 10x. Okay, this is what we need to prove. That is cos, first we'll take LHS, that is cos 9x minus cos 5x upon sin 17x minus sin 3x. Okay. Now we have, that is cos x minus cos y. So we'll put the identity here, that is minus 2 sin x plus y by 2 into sin x minus y by 2 upon, now sin x minus sin y will be 2 cos x plus y by 2 sin x minus y by 2. So we can see here directly we can reduce this. So I got what? Minus sin 2x upon cos 10x. Okay, which is required in the RHS. Okay, see this. Now try to solve second numerical we have. Now the next numerical which we have is sin 5x plus sin 3x upon cos 5x plus cos 3x is equal to tan x. Okay, let us see how we can solve. We'll apply the identity sin x plus sin y, that which identity will apply. Now sin x plus sin y, that is 2 cos x plus y by 2 sin x minus y by 2. Okay, here also I am not trying to solve LHS first. Here in this also we need to prove LHS is equal to RHS. Now let us see what we can do. A cos x plus cos y, so it will be 2 cos x plus y by 2 and cos x minus y by 2. Okay, so here we can reduce directly and we got what? Now we'll try to sort it out. So now let's solve it. So we got this, that is, now what we can solve is sin x upon cos x, that is called tan x. What we required in the numerical is now LHS is equal to RHS. Okay, so that is how we try to sort it out. Now we have just seen the form numerical we have just solved. Sin x plus sin y upon cos x plus cos y. Identity will be 2 sin x plus y by 2. Identity will be 2 sin x plus y by 2 and cos x minus y by 2. And here I have used cos x plus cos y, that is 2 cos x plus y by 2 and cos x minus y by 2. So these two identities I have used, where sin x plus sin y is equal to and cos x plus cos y. Okay, so these two identities I have used, and finally I got my answer, that is tan for x. Okay. Now let us try to solve more numerical. Now I have one more, that is sin x minus sin y upon cos x plus cos y. Here we know the identity we have sin x minus sin y, that is 2 cos x plus y by 2 sin x minus y by 2. And here I am using it cos x plus cos y, that is 2 cos x plus y by 2. 2 cos x plus y by 2 and cos x minus y by 2. So this what we got is sin x minus y by 2 upon cos x minus y by 2, that is called tan x minus y by 2, that is equal to RHS. This we have solved LHS, hence proved. So we can solve lot more numericals based on the formulas which we have discussed earlier. Okay, now we'll try to solve more numerical. We have now next numerical. Now we have the next numerical, that is sin x plus sin 3x upon cos x plus cos 3x is equal to tan 2x. So now we'll try to solve first LHS. What LHS is given? Sin x plus sin 3x upon cos x plus cos 3x. Here we will apply identity sin x plus sin y, that is 2 sin x plus y by 2 cos x minus y by 2. Similarly, we will apply cos x plus cos y, that is 2 cos x plus y by 2 cos x minus y by 2. Okay. Identity we are using is sin x plus sin y, that is 2 cos x plus y by 2 and cos, we have sin. Okay, and here we have cos x minus y by 2. Okay, and another identity which we have used here, that is cos x plus cos y, that is 2 sin, we will use here 2 cos x plus y by 2 and cos x minus y by 2. Okay, so we have used two identities here. So now you can see it will be reduced directly. So now sin 2x upon cos 2x is equal to tan 2x is equal to RHS. Okay, so we can solve such kind of numericals based on the trigonometric formulas. So we can see the formulas plays very important role in such kind of numericals. Now let us try to solve one more numerical we have, that is sin x minus sin 3x upon sin square x minus cos square x. We need to prove to sin x. Now let us see how we can solve this numerical. First of all, we'll sort it what is LHS. That is what LHS is given: sin x minus sin 3x upon sin square x minus cos square x. Okay, so we'll apply the identity, that is sin x minus sin y. That is, I will got here 2 cos x plus y by 2 sin x minus y by 2. Okay, so now here I am getting this sin square x minus cos square x. Okay, now the next step will be, we'll sort it out here. You can see, you can reduce it here itself. So you got what? 2 cos 2x, 2 cos 2x sin minus x. Okay, upon, now we can take minus sign common in the denominator. We find cos square x minus sin square x. Okay, now we all know sin minus x is equal to minus sin x. So we got sin x cos 2x. Here also we got cos square x minus sin square x is a formula of cos 2x. Cos 2x. Reduce this, so I got 2 sin x equal to RHS, which is required. So that is how we can solve such kind of numericals. Now we'll try to solve more numerical. Okay. Now let us see the next one. Okay, so now we'll try to solve the next one. They have given is about the cos 4x plus cos 3x plus cos 2x upon, we have sin 4x plus sin 3x plus sin 2x is equal to cot 3x. So now we'll see how we able to solve this numerical. Let us take first LHS. Now what LHS is given? Cos 4x plus cos 3x plus cos 2x sin 4x plus sin, we have 3x plus sin 2x. Okay, now cos 4x plus cos 3x plus cos 2x. What we can do? Take this cos 4x plus cos 2x. Okay, and left side cos 3x. In the denominator also we'll do the same, that is sin 4x plus sin 2x. Keep aside sin 3x. Now we'll apply the identity about cos x plus cos y, that is 2 cos x plus y by 2 cos x minus y by 2. Similar, sin x plus sin y, we got 2 sin x plus y by 2 cos x minus y by 2. So now we can reduce it. So now by this we can see here what we have: 2 cos 3x cos x plus cos 3x upon 2 sin 3x cos x plus sin 3x. Okay, so now what we can do is take cos 3x common from the numerator. So what we left is 2 cos x plus 1. Similarly, we can take sin 3x common from the denominator. What is left with? 2 cos x plus 1. They are reduced. Now we will left with cos x, cos 3x upon sin 3x, that is cot 3x, which is required in the RHS. So finally, just have solved. So we have applied here two identities, that is cos x plus cos y is equal to 2 cos x plus y by 2 and cos x minus y by 2. And what is about sin x plus sin y? Sin x plus sin y is 2 sin x plus y by 2 and cos x minus y by 2. So these two identities I have used in this numerical. Okay, so now we'll solve next one. Now we'll try to solve more numericals here. Let us see. Okay, now the next numerical I have, that is tan 4x, and we need to prove it to 4 tan x 1 minus tan square x upon 1 minus 6 tan square x plus tan 4x. Okay, tan is for 4x. Now let us see how we will be able to solve it out. Now we know we need to sort it out the LHS one first. Now LHS is given tan 4x. Now we will use the formula for that. We can write tan 2x. 2 into, now what is the formula for tan 2x? That is 2 tan square x upon 1 minus 2 tan square x is equal to 2 tan square x upon 1 minus tan square x. Tan square x. Okay. So that is the formula for that. Now see, we have the formula for tan 2x, that is 2 tan x upon 1 minus tan square x. Now here we'll apply again tan 2x, that is 2 tan x upon 1 minus tan square x. Okay, because we have here 2x now, and upon we have 1 minus. Now again we'll try to solve that formula. Tan 2x, that is 2 tan x upon 1 minus tan square x. Okay, whole square, because they have good square, so we will use that one. Now the next thing is, what we can do is just multiply with it. 2 into 2, 4 tan x upon 1 minus tan square x upon, here we will sort it out, 1 minus 4 tan square x upon, now 1 minus tan square x का whole square, a minus b का whole square. So we will apply a square plus b square minus 2ab. Okay. So finally what I got here is, you can take LCM here. Okay. So now 4 tan x upon 1 minus tan square x upon, take the LCM here. So 1 plus tan just power 4x minus 2 tan square x minus 4 tan square x upon 1 plus tan just power 4x minus 2 tan square x. Okay. So now my next step will be, I'll put it here, 4 tan x upon 1 minus tan square x. Now take this upper side into 1 plus tan to the power 4x minus 2 tan square x upon, now I will do this, 1 plus tan of 4x minus 2 minus 4 minus 6. So I will get 1 plus tan to the power 4x minus 6 tan square x. Okay. 1 plus 4, 2. Now here I have this much. So now what we can do here, it is 4 tan x. Okay, so I have taken all this. So I got this one, 1 plus tan to the power 4x minus 2 tan square x upon 1 minus tan square x upon 1 plus tan to the power 4x minus 6 tan square x. So I got this one now. Now this will say that, now we can see here, that is what is left here, that is after taking this LCM 1 minus tan square is the whole square, so we'll keep it this only after taking LCM. Now what is left, reduce 1, so I got my answer, that is 4 tan x 1 minus tan square x upon 1 plus tan just of 4x minus 6 tan square x, that is equal to RHS, which is now required. Okay, so you can see here we have applied the identity, that is tan 2x is equal to 2 tan x upon 1 minus tan square x, but here it is 2x, so we'll apply here again, we'll apply same identity. We have applied this identity twice. Here also tan square 2, it will be whole square because it is given in square form. Then you know we'll multiply with that, then we got this one. Okay, so after taking the LCM here, opening bracket here, a minus b whole square, a square plus b square is 2ab. We'll sort it out. We'll keep it here this square. Okay, then so that after taking upper side, it will be reduced by 1. So same thing, and here we'll left with this only. 1 plus tan is 4 and 6 tan square x, which is required in the numerical. So now we'll try to solve the next numerical. Okay. Now next one we have, that is cos 4x. Cos 4x is equal to 1 minus 8 sin square x cos square x. Okay. So now let us see how we can prove. We'll take the LHS first, that is cos 4x. So we can write it cos 2 into cos 2x. So now cos 2x formula we will use, that is 1 minus 2 sin square x. Now 1 minus 2, now sin 2x will be 2 sin x cos x ka whole square. So I got 1 minus 2 into 4 sin square x cos square x. So 4 into 2 8 sin square x and cos square x, which is required is our RHS. So we can see how we can solve such kind of numerical. So now we'll try to solve one more numerical we have, that is cos 6x. We have, that is cos 6x is equal to 32 cos की power 6x minus 48 cos की power 4x plus 18 cos square x minus 1. Okay. So now let us see how we can solve it, such kind of numerical. Now we have, let's take LHS. Cos 6x. So how we'll solve? We'll write cos 3 into 2. Now we'll use the formula of cos 3x, that is 4 cos cube x minus 3 cos x. Okay. That is a formula, 4 cos cube x minus 3 cos x. Now cos 2x will use cos 2 cos square x minus 1 whole cube minus 3 into 2 cos square x minus 1. Okay. So now 4 a minus b whole cube will use here a cube minus b cube minus 3 into ab into a minus b. It is a minus b I am using here, a minus b. So cos square x minus 1. Okay. So what we have, this one minus 6 cos square x plus 3. We have just multiply with that. So we have sorted out with this 32 cos to the power 6x, okay, minus 4 minus 24 cos square x. Now cos square x minus 1. Now minus 6 cos square x plus 3. Okay. So now we can see here 32 cos raised to power 6x. Okay. Then we have, if I say this, minus 24 cos 4x plus I have 24 cos square x minus 6 cos square x plus 3. Okay. So now I got 32 cos to the power 6x minus 24 cos to the power 4x plus 18 cos square x plus 3. Now plus 3, minus 4 plus 3, it will be minus 1 here. Okay. So it will be minus 1 here. Okay. So that is how we able to solve such numerical. Okay. Now it is. So now we have seen that in this we have used two formulas, that is cos 3x is equal to 4 cos cube x minus 3 cos x, and we have used cos 2x, that is 2 cos square x minus 1, and one more we have used, that is a cube minus b cube, that is, we have used that formula a minus b whole cube, that is a cube minus b cube minus 3ab into a minus b. So these three formulas we have used to find our answer, and we finally got our RHS, that is equal to RHS 32 cos power 6x minus 48 is power 4x plus 18 cos square x minus 1. That is how we able to solve it. Here we have a is 2 cos square x, b is 1. So we have used the identity, that is a cube a minus b whole cube, that is a cube minus b cube minus 3ab into a minus b. So that is how we able to solve it. Now we'll solve one more numerical based on these formulas. Okay. So now we have, that is cot x cot 2x minus cot 2x cot 3x minus cot 3x cot x is equal to 1. Okay. Now we'll see how we can sort it out this. Let us take LHS. Now cot x cot 2x minus cot 2x cot 3x cot 3x cot x. So what we can do in such kind of numericals, x minus cot 3x common here. So here cot 2x plus cot x. Now in the next step we'll see cot x cot 2x minus, we can net cot 3x is equal to cot 2x plus x, and we have cot 2x plus cot x. Okay, I can net 3x is equal to 2x plus x. Now my next step will be what? Cot x plus y formula, that is cot x cot y minus 1 upon cot x cot y. Okay. Now what is left with us is, after using that identity, now cot x cot 2x, open the bracket, cot 2x cot x plus 1. Now left with 1 is RHS. So that is how we use the identities. Here I have used one formula. We can write here cot x plus y is equal to cot x cot y minus 1 upon 1 plus cot, here I am using it, cot x cot y minus 1 upon cot x plus cot y. So that is how we can solve such kind of numericals based on the trigonometric formula. So the most important thing is we need to take care of the formulas. If we don't know the formula, we can't solve such kind of major problem. So that's all today.